In this video, we are going to solve a problem x plus 3 multiplied by x plus 5 multiplied by x plus 7 multiplied by x plus 9 is equal to 9. Of course, the question is to find all solutions respectful of x. The dirty method to solve this equation is to expand the expression on the left side of the equation. Of course, that is correct to do, and for that you can apply Ferrari's formulas for solving a polynomial equation of fourth degree. We are not going to do that in this video. Here I want to show you a neat trick that will separate someone who is experienced in solving these types of math problems from everybody else. You see, the more problems you solve, the greater your skill to observe hidden patterns becomes. And of course, those hidden patterns are going to simplify everything. Now, if you want to expand this expression, you will get an equation x to the power of 4 plus 24x cubed plus 206x squared plus 744x plus 945 is equal to 9. And this equation is not that easy to solve. A quick question and an important one that I want to address at this point is how many solutions do you expect to get for this equation? We have a quadratic equation here, which means that the highest degree of a polynomial, the degree of a leading coefficient, is number 4. That means that our equation has 4 solutions. Let's observe the starting equation x plus 3 multiplied by x plus 5 multiplied by x plus 7 multiplied by x plus 9 is equal to 9. We can observe that all these constants, 3, 5, 7, and 9, form an arithmetic sequence with a common difference of 2. The average of these 4 numbers is going to be 6. We can find that average by finding the sum of all these numbers. So we have 3 plus 5 plus 7 plus 9, and then we are going to divide it by the numbers of numbers that we have in the sum, and that is 4. So this is equal to 24 divided by 4, and that is equal to 6. Now we are going to center this equation around the number 6. So we have x plus 3 multiplied by x plus 5 multiplied by x plus 7 multiplied by x plus 9 is equal to 9, and we are going to center that around number 6. We are getting x plus 6. Remember, we have 3 here, so 6 minus 3, that is equal to 3. Multiplied by x plus 6, we have 5 here, so we are going to take away just 1 to get that number 5. Again, x plus 6, we have 7 here, so we are going to add 1 to get that to be 7, and we have x plus 6, and we have number 9 here, so we are going to add 3 to get that number 9 as their sum, and that is equal to 9. We have x plus 6 part as common in all of these terms, so we are going to introduce a substitution that y is equal to x plus 6. This substitution is important. We are going to come back to it later. And we are going to make things simpler by using this substitution. The equation then becomes y minus 3 multiplied by y minus 1 multiplied by y plus 1 multiplied by y plus 3 is equal to 9. And now you can see our result of centering an equation around its average. We get a symmetrical equation as y minus 3 on this part corresponds to y plus 3 on the other end of the equation. And here we have y minus 1 and y plus 1 that correspond to each other. Now that we have grouped these terms together in pairs, they are of the form a minus b multiplied by a plus b, and that is equal to a squared minus b squared, which is the famous formula for difference of squares. The equation then becomes y squared minus 3 squared multiplied by y squared minus 1 squared is equal to 9, or y squared minus 9 multiplied by y squared minus 1 is equal to 9. Again, this equation can be reduced to a better looking form. So let's repeat the process one more time. We are looking for the average of numbers 9 and 1, and that is 1 plus 9 divided by 2, as we have two numbers in the sum, 10 over 2, which is equal to 5. And now we are going to center the equation around the number 5. So we have y squared minus 5 minus 4. This is equal to minus 9. And we're going to multiply that by y squared minus 5 plus 4. Minus 5 plus 4 is negative 1, which we have here. And that is equal to 9. Y squared minus 5 is repeating in both of these terms of our product, and we are going to introduce the substitution that z is equal to y squared minus 5. By using the substitution, we are going to get that z minus 4 multiplied by z plus 4 is equal to 9, and this is again of the form a minus b multiplied by a plus b is a squared minus b squared, so we have that z squared minus 4 squared is equal to 9, or z squared minus 16 is equal to 9, which gives us that z squared is equal to 25. And from this position we get two solutions. Z is equal to 5 or Z is equal to negative 5. How do we get here from this position here, where z squared is equal to 25? We are going to take the square root of both sides of the equation, and that we get a square root of z squared, that is absolute value of z, and square root of 25 is 5. Remember, it's not plus or minus 5. Square root is a function. It has only one solution. The solution is unique, just number 5. That plus or minus that we get for solving this equation comes from the absolute value. So we are going to get for z, which is larger or equal to 0, that z is equal to 5. And in the case where z is negative, we get that negative z is equal to 5. So z is equal to negative 5. And we get the two solutions that are expected. So just a little note here. Solving a quadratic equation of this form, z squared is equal to 25, is going to give us the solutions plus 5 and minus 5. The square root of 25 is different from solving an equation like this. It has only the value of 5. So we have the solutions that z is equal to 5 or z is equal to negative 5. And at this point we are going to return the substitution. Z was y squared minus 5. So we had that y squared minus 5 is equal to 5, or that y squared minus 5 is equal to negative 5. Y squared is then equal to 10, or y squared is equal to 0. Then we have that y is equal to the square root of 10, or that y is equal to negative square root of 10 from this term here, and this y squared is equal to 0 is going to give us that y is equal to 0. Let's return the substitution. Y is equal to x plus 6, and then we get that x plus 6 is a square root of 10, or that x plus 6 is negative square root of 10, or that x plus 6 is equal to 0. we have that x is then equal to negative 6 plus the square root of 10, or that x is negative 6 minus the square root of 10, or that x is just negative 6. And finally, these are the solutions of our problem. You can recall that I have mentioned that we are expecting 4 solutions for this problem, and now we have just these 3 solutions. So what is happening? We had here that y squared is equal to 0. So from y squared is equal to 0, we got that y is equal to 0. Here in y squared is equal to 0, we actually have a root of a second degree y is equal to 0. So y squared polynomial can be written as y minus 0 multiplied by y minus 0, and 0 appears here 2 times in these linear terms. So solving the equation is y minus 0 multiplied by y minus 0 is 0, and that is where we get that y minus 0 is 0, or y minus 0 is 0, so y is equal to 0, or y is equal to 0. Y is equal to 0 is a root of a second degree of a polynomial. From this root y is equal to 0, we get that root is x is equal to negative 6 when we return the substitution, and that is the root of our beginning problem. And this x is equal to negative 6 is again a root of a second degree. So finally, we have the solutions of our problem. X is equal to negative 6 plus the square root of 10. This is a root of first degree. We have that x is negative 6 minus the square root of 10. Again, this is a root of first degree. And we have that x is equal to negative 6. And this is a root of second degree. And that is 1 plus 1 plus 2, which gives us 4 roots. And those are all solutions of our problem. So thank you for watching, and I'll see you in the next video.